Right. Uh, March 2025 question paper. Uh, 9 questions. We'll go one by one without wasting much time. The first question being asked was explain the requirements of the classification of a society, including the role of classification society in ensuring compliance with safety and standards of construction. Like we all know that classification involvement is in three parts. One is during the design approval stage, the second is during the construction of the vessel, and third is during the operational life of the vessel. All right, initial classification is also there. Periodic post construction like the annual surveys, intermediate surveys, special surveys, dry dock surveys, these are all there. Now, classification of a ship is a system of verifying vessels compliance with specific technical standards regarding design, construction, and maintenance. It ensures that ship is structurally sound and mechanically reliable for its intended service throughout its life. Design approval, like we already spoke, the plan specifications of hull machinery electrical control system must be submitted to the classification society first. Second is approval must meet the society's rules and guidelines. The third part is the construction supervision that must be carried out in the presence of surveyors in the yard. That's why you see during the shipbuilding a lot of classification society who are on board. Continuous oversight of classification surveyors at the shipyards, definitely. Even India, a lot of ship construction is being given on, is being focused because the yards of China, Korea, and Japan are totally full, and the cheapest way to build any ships will be in India. So if you see places like the Cochin shipyard, the Hindustan shipyard, Goa Garden Reach, or Goa on Mascon Dock, or other uh, lesser known shipyards are occupied with a lot of projects coming to India. And like I said, the initial classification society, hull machinery and relevant machinery systems are inspected before the vessel is assigned a class. Upon satisfactory completion, a class certificate is issued. Now, the periodic surveys like the annual, intermediate, special survey, bottom survey, this keeps on going throughout the period of life. Role of classification society, it is setting standards, develop and maintain technical standards for ship design and construction. Survey and certification, carry out inspection and issue classification certificates upon satisfactory compliance. Statutory functions delegated by flag state, often authorized by government to conduct statutory surveys for IMO conventions. Risk assessment and safety enhancement. Uh, Identify potential risk through structural or system deficiency and purpose, and propose corrective actions. Technical support and consultations. Provide technical advice during construction, repair, or conversion projects. Right? Even during any conversion projects, technical support and consultation is required. Q1, discuss the scenario where ship is classed by two classification society. How is this process managed, and who is responsible for conducting statutory surveys and audits in such cases? Dual classification scenario. A ship may be classed by two classification society under special arrangements, typically when transition from one class society to another. Commercial or owner specific requirements demands a dual class. Yeah, certain have been couple of vessels which have a dual class. Yes, mutual recognition exists between the society. This arrangement is governed by the International IACS, Association of Classification Society, and procedures in bilateral agreements. Now, coming to the management of dual classification, mutual recognition and transfer agreement. One society acts as a lead class and the other as a supporting class. Lead division of responsibility is established. Coordinated surveys. Surveys are jointly planned to avoid duplication. Each society covers specific areas. Example: hull by one and machinery by another. Harmonized rules. Both societies agree to apply the same or compatibility rules. Avoid conflict in technical requirement or survey findings. Survey reports and findings again shared between societies. Unified reporting helps in class maintenance. Responsibility of the statutory survey and audits. Flag state authorization is key. RO authorized by the flag administration is responsible for statutory survey. Usually, only one class society is designated for statutory surveys, even if the dual class exists. This question is pretty basic, and not much of an explanation is required, and we can cover and easily answer this question. Part 2 is define a substantial corrosion in context of ship construction and classification requirement. What criteria are used to assess substantial corrosion during inspection? Discuss the steps taken to address substantial corrosion during uh, renewal surveys, including inspection, technical repairs, repair methods, and the role of classification society in ensuring compliance. Uh, Again, the definition of substantial corrosion is an extent of corrosion such that assessment of corrosion pattern indicates wastage is in excess of 75% of allowable margin, but within the acceptable limits of classification rules. It is considered not yet critical but nearing the limit of acceptable structural thickness and requires attention to prevent structural failure. It is considered not yet critical but near the limit. So 75% of the limit, if it reaches the 75% of the limit, then you call it a substantial corrosion, right? And requires special attention to prevent structural failure. Criteria for assessing substantial corrosion, again, measured thickness and original thickness. Use a ultrasonic thickness measurement to compare actual thickness with original design and minimum allowable thickness. Extent and pattern of corrosion. Localized corrosion or general wastage is assessed. Corrosion in critical areas, bulkheads, tank boundaries, frames is scrutinized more rigorously. Structural location. Structural importance affects tolerance. High stress areas, sticker thresholds, non critical areas, some relaxation may be allowed. Coating conditions. Poor or failed coatings are considered uh, indicators of potential indicators of potential for further corrosion. IACS guidelines, special criteria laid out for tankers, bulk carriers, and general cargo ships. 75% of wastage of corrosion addition triggers substantial corrosion classification. Okay, so to remember the points, measured thickness versus original thickness, extent and pattern of corrosion. What is the pattern of the corrosion? Is it localized corrosion or it's a general based? Also, the location of corrosion matters. Is it non-critical area or critical areas? Coating condition. Poor or failed coating are considered indicators of potential for further corrosion. ICS guidelines. Specific criteria laid out for tanker, bulk carrier, and general cargo ships. Example: 75% wastage of corrosion addition triggers substantial corrosion and classification. Steps to adhere to substantial corrosion during renewal surveys. Inspection techniques is basically visual or ultrasonic or sometimes close up. ನೀರು ತೆಗಿಬೇಕು. Gender equality is one of the goal of United Nations Substantial Development Goal. Discuss the importance of gender diversity in maritime industry and challenges faced by women in the sector. The importance of gender diversity in maritime industry, inclusive growth and innovation. A diverse workforce encourages different perspective, better problem solving, and creativity. Address labor shortages. The maritime industry faces skill shortage. Tapping into female workforce helps bridge this gap. Improved operational efficiency. Studies how the gender diverse team enhances decision making management efficiency. Better representation. Gender diversity ensures that the maritime sector reflects the global population, promotes social justice, fulfillment of SDG Goal 5, contributes standards to Substantial Development Goal 5, gender equality, fostering equality and empowerment. So the 5 points again here is inclusive growth and innovation. A diverse workforce encourages different perspective, better problem solving and creativity. Addressing labor shortage again, maritime industry faces skill shortages and tapping into female workforce helps bridge this gap. Improved operational efficiency. Studies how the gender diverse team enhances decision making and management efficiency. Better representation. Gender diversity ensures that the maritime sector reflects the global population and promotes social justice. Fulfillment of SDG goal number 5. contributes directly to sustainable development goals, gender equality, fostering equity and empowerment. Challenges faced by women in maritime sector, again cultural and social barriers, persistent gender stereotype, male-dominated work environment, societal expectation deter women. Lack of representation. Women make 1 to 2% of the global seafarer workforce, mostly in hospitality roles. Harassment and discrimination. Incidents of harassment, bullying, unequal treatment at sea remain significant concern. Limited career progression. Fewer women are promoted to senior or decision-making roles on board and ashore. Inadequate facilities. Ships are often not designated with facilities suited for female crew. Work-life balance. Long sea contracts, isolations make it hard for women to balance family and career. Explain the role of International Maritime Organization in promoting gender equality in shipping and elaborate on the initiative taken by the Indian government to reduce the gender gap in maritime workforce. IMO Women in Maritime program since 1988 they are present, launched to support integration of women in the maritime sector. Empowering women in maritime initiative encourages training, technical cooperation, leadership opportunities for women. IMO Regional Association supported the formation of 7 women in Maritime Association in Africa, Asia, Latin America, and Caribbean. International Day of Women in Maritime. Usually, an annual analysis of awareness and highlights achievements, capacity building. Again, IMO supports scholarship for women to attend maritime institutions, collaboration with UN and industry stakeholders, works with ILO and other bodies to foster the global maritime gender equality. Initiatives by Indian government increases enrollment in maritime institutes. The DG Shipping has encouraged admission of female cadets in maritime training institutes. Financial assistance is being provided, scholarship and fee waiver. Gender-specific guidelines and safeguards are in place. Promotion of campaigns, participation in IMO campaigns and the National Maritime Week events highlight female achievers. Support for maritime women forums. India actively supports ISTA Women International Shipping and Trade Association, which works on mentorship and advocacy. Government appointments increase female representation in Indian maritime administrative and leadership roles. While progress has been made globally and nationally, the significant structural and cultural changes are still required to ensure gender balanced and inclusive maritime industry. Maritime industry have taken several initiatives to explore new digital technologies, and 3D printing is one of such initiatives. With brief introduction on the principle of 3D printing, explain the following. A. Explain the concept of 3D printing and its working principles. B. Discuss its application in maritime industry. What are the advantages and challenges of using 3D printing technology in shipping industry? Now, part A of the question, concept of 3D printing, also known as additive manufacturing, is a process of creating the three-dimensional solid objects from digital file by layer material addition, unlike traditional subtractive manufacturing, which involves cutting and drilling. So, digital design is the first part. Computer-aided design file or the 3D scan of the object to be printed. Slicing. The 3D model is sliced into thin horizontal layers by slicing software generating G-code instruction for the printers. Material deposition. Based on the type of printer, materials such as thermoplastic, metal, resins, or composites are deposited layer by layer construction. The printer builds the object by adding material layer upon layer until the final shape is achieved. Post processing. Printed parts may undergo finishing process like cleaning, heat treatment, or surface polishing for desired quality and strength. To discuss its application in maritime industry. Spare part manufacturing, on-demand production of critical ship components to reduce inventory and waste of time. Shipbuilding tools and prototypes, fabrication of custom tools, jigs, mock-up parts for shipbuilding and design verification. Repair and maintenance, 3D printing enables rapid repair solution for damaged parts, especially in remote locations, lightweight structural components, use of high performance polymers, composite materials to replace heavy metal parts. Design customization and optimization enables customized complex geometric that are difficult to produce through conventional methods, enhancing fuel efficiency and design. What are the advantages and challenges of using 3D printing technology in the shipping industry? Okay, what it does is it reduces the lead time, lower inventory costs, design flexibility, sustainability, and remove manufacturing. Challenge: material limitations, limited range of certified grade material, especially for critically loaded wearing components. Lack of standardization are the challenges. Material limitation is there. What are the perils of the sea which are covered in a marine insurance contract? What can an insured do to cover a peril other than an insured peril of sea? Explain with examples. Also enumerate the peril which are covered under maritime insurance, but the onus of proof is upon the insurance to prove the assured want due diligence to avoid claims. Definition of peril of sea. The peril of sea refers to fortuitous accidental events that are marine character causing loss or damage to vessel or cargo during insured voyage. Common peril of sea covered under marine insurance: heavy weather storms, violent weather condition causing cargo ship flooding or hull damage, stranding or grounding, vessel running aground due to navigation errors or poor weather, collision, ship to ship or ship to object collision resulting in structural or cargo damage, sinking or capsizing, total loss due to ship instability, flooding and or hull breach, fire and explosion, caused by engine failure, cargo reaction or external attack. Piracy and theft. Modern marine insurance policy include piracy, general average sacrifice, a loss arising from voluntary sacrifice to save the voyage, that is jettisoning the cargo, jettisoning and washing overboard, cargo thrown overboard to stabilize the ship or lost during a rough sea. How to cover non-insured perils. If a peril is not covered under standard maritime policy, the insured can seek protection by purchasing additional add-on cover like war and risk clause, institute of cargo clause B and C, broader coverage options than standard terms, delay in transit clause for loss to unexpected transit delays, specific marine extensions, reefer cargo clause for perishable goods, cyber risk clause for electronic and navigational system interference, tailored insurance policies, negotiated bespoke insurance contracts to cover business-specific perils. Examples of non-insured perils that may require extension: delay in delivery, not covered unless specifically insured. Inherent vice, damage due to nature of goods is excluded. War or political unrest, need separate war risk cover. Again, peril where the onus of the proof is on the insurer to prove lack of due diligence. In certain insured perils, the insurer may deny claim if they can prove the assured failed to exercise due diligence. Peril covered. Onus insurer to prove the due diligence. Fire or explosion, claim payable unless insurer proves poor maintenance or negligence. Right? Stranding or grounding, insurer must prove improper navigation or known defects. Sinking or capsizing, covered unless proven vessel was unseaworthy and owner knew. Collision, claim paid unless proven improper crewing or ignored maintenance. And breakage and damage, covered unless poor package or negligence by the assured is proven. So the key principles here are: burden of proof is on the insurer to prove that the loss was due to the assured lack of due diligence. The prudent ship owner standard is applied. And again, in conclusion, marine insurance covers a wide range of perils of sea that are fortuitous and accidental in nature. However, a non-insured peril, additional coverage or special policy must be taken, while many perils are covered under the standard marine policies. In certain situations, the insurer can deny claim by proving the assured failed to take proper precautions, emphasizing the importance of good seamanship and operational diligence. The HNS Convention is expected shortly to come into force. Explain the following in respect of the convention. List and give example of substances covered under the convention, type of pollution, and subsequent loss of damages which can come under this convention. Why would oil product tankers probably require to have certificate and all three conventions, that is CLC, bunker, and HNS? Correct. Now list and give examples of substances covered under this HNS Convention. HNS, the Hazard Noxious Substance Convention, adopted in 1996 and amended again 2010 protocol, establishes a legal framework for liability and compensation for damage caused by maritime transport of hazardous and noxious substances. The substances covered are oil products other than persistent oil under CLC. Example: gasoline, diesel, jet fuel. Chemicals listed in MARPOL Annex 2: noxious liquid substances, example sulfuric acid, methanol, styrene. Liquefied gases comes under IGC, that is LPG, LNG, and ammonia. Solids in bulk covered under the IMSPC code. Package HNS listed in IMDG code, example batteries, pesticides, explosives, radioactive materials. Type of pollution, subsequent losses or damages which can come under this convention. HNS convention covers both pollution and physical damages arising from the incident involving HNS substances during maritime transport. Types of pollution and losses covered: personal injury or death to crew, passengers, or third parties due to exposure or inhalation of toxic substances. Proper damage to port infrastructure, cargo vessel, or nearby property. Environmental damage, marine pollution, contamination of fisheries, coastal ecosystem, and water bodies. Preventive measures, costs, expenses for salvage, cleanup, firefighting, chemical neutralization, even if damage is averted. Economic loss, loss of income due to pollution or access restriction. Okay, the question number 7 is IMO introduced the EEDI requirement, Mark 1 and H 6, Chapter 4 to new builds after 2013 as a measure towards reduction of CO2. Explain the various design features adopted in the new build vessels to comply with the EEDI framework. Again, IMO introduced the EEDI requirement under MORPOL Annex 6, Chapter 4 for new build ships in 2013 as a measure towards reduction of CO2 emission from shipping. And again, there are three phases: the phase 1, 2, 3. Under phase 1, which was between 2015 to 2019, a 10% reduction was required. Under phase 2, 20 to 30% reduction, that's from 2020 to 29. And phase 3, that is 30% reduction, 2025 to 2030. Design feature adopted to meet EEDI phase 2 requirements. Again, to comply with the EEDI phase 2, ship designers and builders are incorporating a range of energy efficient technology and design optimization. This includes hull form optimization, streamlined hull shapes to reduce water resistance, use of bulbous board designated for actual operating at different speeds, hull surface coating to minimize drag, propulsion efficiency involvement, energy efficient propellers, optimize blade designs and large diameters, reduce fuel consumption. Again, duct and fins, improve water flow into the propeller and enhance thrust. Contra rotating propeller is also there, podded drives, as we all know, in these passenger vessels. Lightweight construction, use of high tensile steel, aluminum alloy, composite materials to reduce ship weight. Lighter ship requires less propulsion, hence lower emission. Main engine improvements, again installation of Tier 2, Tier 3 compliant engines, low speed, super long stroke with higher thermal efficiency, electronic engine control system to optimize combustion and fuel injection, waste heat recovery systems, recovering exhaust gas heat to generate additional power to onboard use, reduce fuel consumption and improve overall energy balance. Air lubrication system, air bubbles are pumped beneath the hull to reduce the friction between the hull and the water. Proven to reduce resistance by 5 to 10%. Energy saving devices, Mewis duct, Becker Mewis duct, rudder bulbs, It's important. Renewable and hybrid power integration, wind assisted propulsion, solar panel for auxiliary power, battery hybrid system. Speed reduction strategy. Ships are optimized for lower speed ship service speed and with significantly reduce the fuel oil consumption and emission. Onboard energy management. Installation of energy efficient lighting with variable frequency drives is good. Now coming to hull and propeller maintenance is gaining popular with the recent high stress on the energy efficiency of ship. Write short notes on the following: the hull roughness management, condition-based propeller maintenance, propeller coating and polishing. Key aspects: cause of roughness is marine growth, algae barnacles, degraded paint layers, corrosion and surface pitting. Impact of efficiency: even slight roughness increases drag. A 10 to 20% increase in fuel consumption can occur due to poor hull condition. Management technique: use of anti-fouling coatings, regular hull cleaning, either at dry dock or in water using ROVs or brush system, surface preparation, and smooth reapplication of coating during dry docks. Hull performance monitoring. Some systems use sensors and softwares to monitor resistance trend and recommended cleaning intervals. Condition-based propeller maintenance. Monitoring techniques, fuel consumption trends, shaft power versus speed data, underwater inspection with camera or ROV. Indicators of propeller degradation. Drop in propeller efficiency, vibration due to fouling or imbalance, cavitation and surface pitting. Benefits of condition-based maintenance. Timely polishing or repair only when needed. Reduce unnecessary downtime, maintenance cost. Supports continuous compliance with EEOI CI goals. Tools used: performance monitoring system, torque meter, hull performance software. Propeller coating and polishing. Purpose: again, prevent biofouling, reduces surface roughness, improve hydrodynamic flow. Types of coating again is foul release coating, hard coating. Benefits: enhances fuel efficiency, reduces cavitation and erosion, longer intervals between cleaning is important. Propeller polishing process done in water using divers or ROVs, uses abrasive pads or discs to restore smoothness. Frequency: every 6 to 12 months it is being carried out. Now again, an Indian flag vessel collided with another vessel off the coast of India, resulting in loss of lives, vessel damage, and an oil spill. In accordance with the provision under the Merchant Shipping Act, what steps should be initiated and who should initiate such steps for the safety of the ship and marine environment? Okay. A marine casualty involving Indian flag vessels in Indian waters, legal safety and environmental responsibilities under the Merchant Shipping Act 1958. In addition to the IMO Convention of Marpol Solas Colrane, the steps involves reporting, investigation, pollution response, search and rescue, and preventive measures. Now, immediate action to be taken: shipboard emergency response ensures crew safety and account for missing persons. Active emergency plans stop further oil discharge using onboard pollution contamination measures like closing walls, etc. Transmit distress messages if assistance may be needed. Assess navigation hazard. Now, reporting obligations, notification to authority initiated by ship owner master as per the section 355 of Merchant Shipping Act 1958. Report the incident to the DGS and nearest Maritime Rescue Coordination Center. Submission of formal incident report as per MS notice. Preliminary incident report must be filed in 24 hours. Okay, detailed report Form 20 should be submitted to the MMD. Governmental and statutory actions initiated by Maritime Casualty Investigation as per the Part 13 of the MSA Act. The DG Shipping or the appointed officer, principal officer of MMD, initiates inquiry or investigation. Investigation includes assessment of cause of collision, loss of life, environmental damage and navigational violations, pollution control and maritime environment protection. Lead agency for oil spill response in Indian waters, deploy contaminant boats, skippers, dispersant surveillance aircrafts. Activate National Oil Spill Disaster Contingency Plan. Monitor cleanup operations and impose penalties if required. Port state measures. Nearby port may deny entry or impose port control measures. Port authorities may assist in emergency towing, salvage, or pollution control. Legal and civil liabilities. If negligence or misconduct is established under the Action Section 361, may lead to suspension or cancellation of master COC, fines and imprisonment, civil claims for loss of life or environmental damage, insurance and liability cover, ship owners to activate P&I club cover for pollution liability, third party damage, compensation for victims. If oil spill is significant, CLC obligation may apply. Preventive and long-term measures, safety review and compliance check. The ISM code audits and re-evaluation of ship safety management system, training of bridge team and review of navigation practices. Environmental restoration. Coastal state may mandate restoration of marine ecosystem, monitoring of long-term pollution impact. That is MOEF and CC, Indian Coast Guard again. In conclusion, in the event of collision involving life pollution, Merchant Shipping Act, swift action by the ship's master, owner, followed by coordination response by the DG Shipping, MMD, and Indian Coast Guard ensures safety, reporting, investigation, pollution control are vital to protect human life, property, and marine environment. Please do subscribe to the channel, and you will be getting a lot of updates on the questions being asked. We'll try to solve and address to most of the questions, making it helpful to all the people who are giving their exams. I again request you to like and also to subscribe to the channel. Thank you.